Okay, so let's look at example number 16. Again, very similar to 15, but there's no mention of the normally consolidated soil, so probably the soil is not normally consolidated anymore. Yeah, feel free to pause the video for a couple of minutes and we'll be back. Okay, so now we're back. Well, we still have a bunch of information. Let's do a summary that the height of the soil is 5 feet and the initial void ratio, sorry, this is a ratio, not ration. So the E naught is 0.9 and we have the C sub C is 0.35. And we now have a recompression index. So this is something new and we would use the C sub S. That is 0.06. Sometimes we use C sub R. The R is for rebound, but they are pretty much the same thing. And we have the vertical effective stress increase from 1,000 to 1,500, but we also have the pre-consolidation pressure is 1,200, something between. So asking for the settlement of the clay layer. Well, again, and you know me, my preference is to plot a E, the void ratio, versus the log sigma prime. So the interesting part is the pre-consolidation pressure. So let's say if the pre-consolidation pressure is here, 1200, then if we go up, and then you should expect the soil to perform a little bit differently before and after this point. So the soil will be compressed a lot easier if your pressure is higher than 1200 psf, because basically the soil had never experienced anything beyond the 1200 psf. So if the pressure is more than 1200, the soil will be easier to compress. And then we're talking about slope is C sub C beyond 1200. And then same thing, if it's smaller, if the pressure is less than 1200, then the soil has seen this before, and it will be a lot harder for the soil to be compressed. So basically, this is the scenario we're looking at here, that let's say we have 1,000, we have a 1,500. In the middle, that's 12. So we have two sections of the lines that we need to think about, and then also come up with the delta E. If this is delta E1, if this is delta E2, as long as we figure out the delta E1 and delta E2, then that is the total void ratio change. We can use that total void ratio change to calculate the settlement, right? So basically, it looks a little bit more complicated, but in essence, it's not. We're still talking about straight lines, but it's just that you have to divide those into two parts, and each part have a different slope. So if you want to calculate the delta E1, then what we're talking here is use the recompression index, that C sub C time the log 1200 minus log 1000. So that would give you the delta E1, which is about 0.00475. And then delta E2, now the slope has changed, so we're talking about log 1500 minus log 1200. So basically that is the distance on the x-axis between those 2 points, and we multiply that by the C sub C. So that would give us 0.0339. And the total void ratio change is delta E1 plus delta E2, that is 0.0387. So with the delta E, with the new delta E, calculating settlement is still the same equation. Delta E over 1 plus E naught initial void ratio times the thickness of the soil, which is 5 feet. So that would give us 1.22 inches. So again, this is 0.9, this is 5 feet. So, yep. So yeah, again, looks a little bit tricky, but if you really understand the plot of the E versus the log sigma prime, and so yeah, you really don't have any needs for all those equations in reference manual. So yeah, that's pretty much about it for this one.